Hi, in this video we'll be looking at the areas between curves. Okay, so let's just have a look at this. I'll explain it in class anyway. I did explain it in class because I've made this video afterwards. But if we have two functions, one function up like that, and I'll do a red function looking like that, then the area between the two curves, in other words, from A there to B there, if we look at the area between those two curves, then that area, sorry I didn't mean to make it look like that, definitely goes down there, the area between those two curves will be the integral from A to B, and I forgot to label, let's say the top function is f of x, and let's say the bottom function is g of x, and that's important, we need to know which one's the top one and which one's the bottom one. That's equal to f of x minus g of x dx. The area is always equal to that. So the top function minus the bottom function. Now, it doesn't matter if it crosses over into area under the curve there. It's taken care of in here. It makes no difference to the integral. You'll always get the correct area. So here, that g of x has wandered down into negative function territory. That is fine. It doesn't matter. If you're trying to find the area under the curve of g of x between the x-axis, yes, it would matter. But the area between curves, it does not matter at all. And so we get this situation here. Easy. No worries. The only other situation you need to worry about is if you had something like this, and so you've got a function, I was hoping for red, never happens, does it? How many times a video does that happen? You've got something like that, and let's say you've got a green function like that, and you're trying to find the area between A and B like that, and let's say this point C in the middle where they cross over. Then what you just have to need to do is to break it up into two pieces. Why do you have to break it up into two pieces? Well, because here the red line is on top and here the green line is on top. So if the green line was f of x and the red line was g of x, then your area will be equal to the integral from A to C, and in this case the red line is on top, so g of x is first, g of x minus f of x dx, plus the area of the next lot from C to B. So from C to B, of which one was on top? F of x is top for this region here, so f of x minus g of x. Beauty. Don't forget your dx, because I almost did just then. And that's it. Alright, so that's the area between graphs. Let's have a crack at a question. So let's have a look at for y equals x squared. Again, I'm picking really easy examples. I don't apologise because I just don't have time in videos to be doing massive partial differentiation and that sort of thing. I've just picked easy math method type examples so I can get through quickly. So find the area between these two. So find area between, and that's all I'm going to say, just get through quickly. Find the area between these two graphs. So firstly, the first thing that we need to do is actually sketch it and have a look at it, because we don't even know what these things look like. I mean, you probably do. So I'm just going to go have them into Desmos. So looking at those two, they look like this. And they cross, it's really important to sketch them because we need to know where they cross over. And so these ones actually cross over at 0, when x is equal to 0, and they also cross over each other at 1. And it's important to know which one is on top. In this case they're quadratic, so they're nice and simple. But the negative x squared graph is on top between those. So let's have a look. So fantastic. So looking at those two graphs, we have x squared. It just never goes to red, does it? You must get sick of me complaining about that. So you've got a terrible looking graph like that, and your negative one that sort of went, again, it's not very good. What we're looking for is that area in there, and they cross over at 0, forgive me for missing there, and they crossed over at 1. It was 1, wasn't it? Just let me check. Yes, x equals 1, they cross over. And so what would the area of this be? Okay, so let's do it. The area between the two graphs will be equal to the integral between 0 and 1 which function is first? We need to do the top function first, which is the negative x squared one. So negative x squared plus, that's a terrible x, negative x squared plus 2x minus the other function, the bottom function, so minus x squared dx. Okay, that's all we got to do. Figure it out. So I'll just simplify 0 to 1, negative x squared minus, that's negative 2x squared plus 2x dx, which is equal to, that goes up to 3, divide by 3, so negative 2/3 x cubed plus x squared between 1 and 0. And we're going to get a negative answer. No, I don't think we are actually. X cubed, so it will be 1, so we get negative 2/3 plus 1 when we substitute it into there, minus, when we put 0 in, we'll just get 0 in there, so there we go. So negative 2/3 plus 1 is 1/3 units squared. And so there's your answer there. Nice and simple, that's good. I'll do a slightly more interesting example because that one's pretty boring. So let's have a look. Let's have the area between y equals, what did I say, cos x, and y equals half, between x equals negative pi on 3 and x equals 5 pi on 3. Let's have a look at that. So what we're talking about here is, I'll just go to the graph again, just show you this. So for this particular graph, get off. These two. So there's the graph in orange of y equals cos x, and there's a graph of y equals half. And we want to do it from here, from x equals negative pi on 3 up to here, x equals 5 pi on 3. So this area in here plus this area in here. Let's just do a quick sketch of that. So something like this. We've got x equals cos. I'm not going to complain. Something like that. Okay, and we've got our y equals half. So going through it like that. And there's your negative pi on 3. That should keep going, shouldn't it? That comes up sort of across there. Sorry for the tacky diagram. Okay, and that point there is 5 pi on 3. Sorry, a bit lame. So what we want to do is we want to know this area, the area between these two graphs over that interval. Okay, so that area there. Let's do it. The area will be equal to, now we've got two separate areas and we need to break them up into two pieces. Okay, we need to know this area here because there the green function, which is cos x, is on top, and here in this area y equals half is on top there, so we need to break it up into the two separate pieces. Okay, also we need to know this intersecting point here. Now you could use algebra and that sort of thing, and you should do that. Just for a quick thing, it goes at pi on 3, so that point there is pi on 3. I've just cheated a little bit because I'm just going to run out of time trying to do this in a 10-minute video. Pi on 3 there. So your area will be equal to, let's do the first chunk first. It'll be between negative pi on 3 and pi on 3, and the top function is cos x minus the bottom function. The bottom function is y is equal to half, so minus a half dx. Right, let's add the second lot. This one goes from pi on 3 up to 5 pi on 3 of the top function, which is y equals half, minus the bottom function, which is y equals cos x dx. And so that'll be your area. At this point you can chuck it into your calculator or whatever, or you could just work it out, but it's going to take a while. I'm not going to spend time doing this, but that would be your area for that. So good. The other thing to notice here is that this is a symmetrical region that has the same area as that, and so just a little tip to make things faster, you could just say that's two lots of from 0 to pi on 3 of cos x minus half dx plus. You could also do something there which with symmetry, but this can often be quite helpful because if you get a 0 into integral, it makes your calculations at the end a little bit more simple rather than having negative pi on 3s and things like that. So that's something to take into account. I'm not going to keep going here. That's just calculations and chucking crap in. So hope you enjoy. Bye.